Intro. So first, knowing the difference between linear and exponential. Linear is like what you learned probably in middle school. Those straight lines that give you equations that look like y equals mx plus b. That's our linear. Our exponential functions have an equation that looks more like this. Y equals a times b to the x. So in this little picture over here, which one is the exponential function, the curved one or the straight one? Okay, good. And then the straight one is the linear, it's more like a straight line. Kind of in the name. So this is the linear because, sorry, I can't see my mouse, it makes it harder. This is linear because it is in the form y equals mx plus b. What's my b, my y-intercept, if it's not written? 0, because we don't usually write plus 0, right? So when I graph my linear functions, I usually start with my y-intercept. So for my linear, I'll have a dot at the 0. And then I use my slope, that's always in front of the x, for my rise over run. Okay, so like from your y-intercept, it looks like we're going up 2, see the way it's counting, don't go up too much. And then to the right one. Up 2 to the right one. Up 2 to the right. So there's that. For filling any table of values, no matter what is going on, you're just plugging into the equation. So like if this is x, then really what I'm doing is 2 times -2. That's what my equation is. What's 2 times -2? -4. Jordan, 2 times -1. No, we're still waking up. I want you to wake up. That's the one you have. Okay, so whether you use calculator or whatever. Bella M, 2 times 0. Romina, 2 times 1. Times 1. It's 2 actually. Anything times 1 is that other number. That's like a identity property. Remy, 2 times 2.
4.
Dash, 2 times 3. And Jordan, back to you. Maybe try seeing the pattern. -2. Now notice what's happening with my y values. What's the pattern here? Like obviously we've got the y's by plugging in our x's, that's how we got them. But what's going on between the y's? How is it changing each time? It's adding 2 each time. So that's like really unique to our exponential function, not exponential, our linear functions, is that it adds the same amount each time. That's why it gives you a straight line. That's why my slope was 2, because it's changing my 2 each time for each interval of 1. Okay. Now our exponential functions, and I could graph all these points, but I don't think I need to. I could make a straight line out of 4 points. But for our exponential functions, we have the equation here. It is in the form y equals ab to the x. What's my a for this one? That's my b. So what's my a if it's not written? My starting value, which is what number in this equation? 2 is the b. It's 1. All right, if it was 0, then the whole thing would cancel out, right? It's 1, that's why they didn't bother to write it. So my y-intercept for my exponential function in this one will be a 1. The rest, I'd say you need to fill out the table of values for sure. But that's because when you plug in 0, Anything to the 0 power is 1. And then the rest you could do also from plugging in. I would need a calculator myself to do the negatives, like I just don't think that way. But 2 to the first power. Bella T, what's 2 to the first power? Jasmine, what's 2 to the second power? Nicholas, 2 to the third power. Okay, good. And then even I need a calculator for the one going backwards. That's just. So use a calculator for all of them, guys. Anytime you have a table of values, even if it's an equation you're not familiar with, just plug it into the variable. So then I have 2 to the -2. That's 0.25. I don't know, that's not gonna fit for me. I'm gonna put 1/4, so that's the same thing. And 2 to the -1 is 0.5. That probably won't fit for me either, so I'll just put 1/2. So everyone see how to fill out a table of values. You plug in your x's to the given equation. And then the rest, that's how you can make your graph. So like exponential functions, that has a 0, 1, a 1 up 2, a 2 up 4, a 3 up 8. And then for my negatives, it's like -1 up, halfway. No, not even halfway, it's like even less than that. And -2 of 0.25. So that's like the pattern it's going in. Exponential functions typically grow at a faster rate than linear functions. They'll always surpass them at some point. And this one, it took an interval of 3, an x value of 3 for it to overtake it. So questions on this one? Okay, that's how you graph. How you fill in a table. Also notice in our y values for our exponential function table, you should be able to see a pattern within the y's. For exponential functions, you're always multiplying to get the next y value. What are they multiplying by in this one? How can I go from 1 to 2? By multiplying 2. And that's why our common factor is 2, that's why the b value is 2, and so forth. If you see it's multiplying in the y values, it's exponential. Good? All right, now this part's your vocab. So exponential functions have a blank as an exponent. All right, they have a variable as an exponent. They blank or blank rapidly. What should go there? Good. You could also say increase or decrease, but grow or decay, I think, is more like in our exponential function unit. So they grow or decay rapidly. They are written in the form y equals a times b to the x, where a is the what? Good, initial value. I like using initial amount because then they like both kind of start with a. And it can't equal 0 because 0 times anything is just 0, so. A is your initial amount. B is the what? Common factor. Yes. And is greater than 0. I don't think we ever had to worry about that in this one, in this unit. Now, what, like, part of the equation can you look at to tell you if it's growth or decay? This is related to something you saw in your test. Like when you have an equation and this number is blank, it's gonna be growth. So if B is greater than 1, that's what it'll go here. And I think that's what it's over here saying, showing you too. But if B is greater than 1, that means it's an exponential growth function. If B is less than 1, that means it's an exponential decay function. So you should be able to see an equation and tell me, oh, since we're multiplying by a number bigger than 1, it's going to grow as time goes on. Don't make up something else. I mean, I appreciate someone trying. But also never leave a test blank. Some of these questions are really like 50-50 chance. Like, is it increasing or decreasing? What else did it ask? I don't know, but I saw some blanks. I was kind of sad about that. Anyway, down here, X is the, what do we usually call our X's? We call it a bunch of different things. I think what it's going for is input, and Y is the output. So then, in that case, I usually tell you X is almost always time. Because in all these situations, we're usually like talking over a period of time. So you could put X is time. But Y is the output. So if we talk about different things like bacteria, growth of algae, dollars, population, Y is just output. So good on that one? Okay, Brady, for this example, that's like to the right of it, what's my A value? Okay, good. Devon, for this example, that's right here, what's my B value? Not 2. 1/2, good. And that's attached to the exponent, that's how I know it's my B value. And Keegan, would this be growth or decay? Is that B value bigger than 1? So it would be decay because 1/2, which if you put it as a decimal, is 0.5, smaller than 1. It would be decreasing over time. Yes. Okay. Gianna R, for the one underneath it. What's my A value? You know, what's my B value? 2, good. Maya, I don't remember your last name, Maya K. Growth or decay for this one? Growth, good, because our B value is bigger than 1. Questions? So then down here, graphs of exponential functions. Let's see if this is important. I guess we could just put that our growth is increasing. And our decay is decreasing. So I really need to know about that. They generally look like either this or this when we're talking about real world problems. But also know, like in lesson 12, we talked about what happens when your A value is negative, when your starting amount is negative, and that would reflect your graph. So I don't know if you want to like add that in somewhere. maybe over here, when you have a negative A, it flips the graph, Just when in doubt, put it in Desmos. Is it increasing from left to right? Then it's growth. Is it decreasing from left to right? Then it's decay. Our biggest equal values. Okay. I don't think we need to talk about asymptotes. It's just a line that it gets close to, but never touches. You don't have to identify it. We can skip that part. Questions at all? Taking the notes? Okay, so backside. This one will go faster. My G. What's my A value for the first one on the back? 4. Good. Gabby, what's my B value? 2. Gianna, S, will this be growth or decay? Is this B value 2/3? Is it bigger or smaller than 1? You're not sure, maybe do 2 divided by 3 in your calculator. So it is decay. And not all fractions will necessarily be decay. It just depends if the decimal is bigger or smaller than 1. But again, also watch out for when they make the A negative, then it'll flip the graph. So just if you're in doubt, make a table of that. Sheffy, for this one, what's my A value? No, try again. So for reference, the equations go like this. So what number is in the A position? It's a 0.5. But yeah, this number right here is my A. Bella M, what's my B value? Romina, will this be growth or decay? Growth. Because 5/2 is the same thing as 2.5. If you put in your calculator, that is definitely bigger than 1. So it should be growth. Okay, now from a graph. Dash, what's my A value from this graph? Where does it start? Where's my y-intercept? All right, we'll come back to you, but you have the A's, try to figure it out. Bella T. Can you find the growth rate? Like, can you figure out what the growth rate is? So we haven't really had to do that as much. I think most of the time you have options and you can just graph and see which one matches it the best. But you should know that A is always your y-intercept. So Bella T, what's my y-intercept for this one? It's at the 1. And then try to find like other areas that you can see very nicely. So what I mean by that is the line would be cutting through the grid, like right in the middle, so we don't have to estimate it. So looking at it, I would probably choose like this point to compare. I can't really see any other nice points. So this coordinate would be 0, 1. This coordinate would be 1, 3. And you can figure out what your common factor is, what your B is, by taking a y value and dividing it by its previous y value. So like 3 divided by 1 is what? 3. So for this one, my common factor is 3. My A or my y-intercept was 1. If it helps you to make it a table, you guys need to understand that a bit better. Remember, your common factor was what you had to do to go from one y value to the next, times by 3. Okay? Now to make the equation, follow the pattern, like y equals a times b to the x. So for this one, my a was 1. I technically don't have to write it because it's a 1, but it's fine. My b value was 3, and it's going to be to the x power. Yes. Yes. Okay. So then dash for this one with my a value. My y-intercept. 2. That's where it touches on the y-axis. So that's where your y-intercept is when x is 0. That's when your time usually starts. So there's that. That is a good one to pick out that you can see pretty clearly. Here's another one that I can see pretty clearly. All you need is 2, I guess, that are right next to each other. This one is also good as well. But I like the positive numbers. I'll probably use those for comparisons, but I'll plot all the coordinates. So this one is at -1, 4. Then we have a point at 0, 2, and a point at 1, 1. And remember, your b is what you have to multiply that to get to the next number. Do you see a pattern? How can I go from 4 to 2 and then from 2 to 1? Dividing by 2, which I'm not going to put a 2 for my b value. Dividing by 2 and timesing by 1/2 are the same thing. But again, you could use that method I showed you, where you just take one of the y values, divided by its previous y value, and that will give you your b. Another one. Click on that. And it is decaying, so I should have a b that is smaller than 1. Right, for the equation, put it together. Y equals 2 times 1/2 to the x. Yeah. Good on that. So now tables, I feel like you guys are pretty good or comfortable with that. What's my a value from my table? Jasmine? A value from a table. So your a value is whenever x is 0, because remember a is like y-intercept. So when x is 0, my a is going to be the y. That's my y-intercept. Gianna R, what's my b value? How does it look like these numbers are changing each time? And if it's hard to tell, use that trick we did earlier, where to find the b value, you take a value divided by its previous term. Take a decimal or a fraction. That's the one you have, so figure it out. If you use a calculator, that's fine. We'll come back to this one. Keegan, what's my a value for this table? Good. Whenever x is 0, my y-intercept. Devon, what's my b value here? 5. That's what I can multiply by to get from 6 to 30, and then see if it's consistent throughout. 30 times 5 is 150. 150 times 5 is 750. So yeah, my B is 5 for that one. Put it as an equation, y equals A times B to the X. Yeah, no, or did you get it? I guess technically no. Sometimes they put f of x, sometimes they just put this and it's an expression, but. So if it's hard to figure out what I need to multiply 12 by to get 3 and so on, sometimes it's not easy to tell. Take one of the values and divide it by its previous value. So I have 3 over 12, which simplifies to what? Not for a whole number, it should be a decimal or a fraction. 12 divided by 3 is 4, but 3 divided by 12 is 0.25 or 1/4 is the equivalent. Okay, either one works. So then when you make it an equation, A times B, I'll use 1/4 because I'm a little out of room, to the X. Almost done. And I'm just gonna kind of glance around, make sure, just kind of eyeball your papers, they don't just hide it from here. The last part are like the word problems, and it looks like we are matching. So from the word problems, that's probably what we started with in math lab this semester, is you wanna use what equation as a reference? Like when there's a percent change, what equation should I use? Okay, perfect. That's still an exponential function. The only difference from this and the other one on your paper is this part. So that if there's a percent change, I can plug it into R, and then just remember that R has to be a decimal. So there's that. It looks like for my matching part, all of them have the same initial amount, so that's not helping me. It's what they're having to multiply by each time. So if Patricia's car starting value was 20,000 and depreciates at a rate of 33% each year, first of all, what does depreciate mean? So really your only options for that one would be B or D, because those are the only ones that have B values that would indicate that it's decreasing. Make sense? Mm-hmm. Now, which one has it where it's 1 minus and what's 33% is a decimal? So 1 minus 0.33, because that's 33% as a decimal, is 0.67. So the one that matches Patricia's is D. Good. Nathan? Okay. Next one, there were 20,000 cases of the flu reported in January. It's expected that each month there will be 1/3 of the cases as there was the previous month. Okay. So is it increasing or decreasing? So then the only other one that is decreasing would be option B. I don't know if that one's a mistake though, because I would think that if it's 1/3 of the previous month. Oh, wait, no, that doesn't. That is, okay. Now, Jenny made a $20,000 investment that's doing incredibly well. It's expected to triple each year. Out of the ones that are left, which one would be tripling or timesing by 3 each time? A. So then by process of elimination, this one must be C. But he has a highly sought after vintage car for $20,000. The value increases at a rate of 33% each year. So in that case, it would be the 1 plus the 0.33, which gives us 1.33. All right, so I kind of eyeballed everyone's papers. I don't think anyone lost points, so I should be able to just give you points for this activity. This is to help you. So I would recommend keeping it probably at least until the final, because you know exponential functions will show up on the final. But you don't need to turn it in. I already kind of looked at everyone's. Any questions? Okay.